Hello dear students of plus 2 medical and non-medical respected teachers. So in this video I am going to discuss again a very important topic, and this topic is what is solenoid and what is the expression for magnetic field due to a solenoid. So first of all we define what is solenoid. So basically solenoid consists of a large number of insulating copper wire turns wound in the form of a cylinder well insulated from each other, and the length of the solenoid is very large as compared to its radius. So the purpose of the solenoid is to produce uniform magnetic field at a point well within the solenoid, that is inside the solenoid. Magnetic field produced is uniform. So that's why it is used to magnetize a magnetic substance by placing the magnetic substance inside the solenoid. It may be air cooled or soft iron cooled. Now, this solenoid carrying current, we have the insulating wires wound on in a cylindrical frame. The solenoid produces a uniform magnetic field well within the solenoid, and a solenoid carrying current behaves like a bar magnet. It behaves like a bar magnet. Magnet lines the force of a north to south, inside south to north. So direction of magnetic field inside is given by this right hand thumb rule. So magnetic field will be directed from left to right along its axis. The current is as shown in figure. So to find expression for magnetic field at a point well inside the solenoid, so consider principal section of the solenoid. Cylindrical frame, magnetic field B along axis, and let a rectangular path PQRS. Let PQ is equal to L. Magnetic field on this PQ will be along the axis of the solenoid. But there is no magnetic field in this along this path, or because these two paths PR and SP are also perpendicular to the axis of solenoid, so there will be no magnetic field. So it means if small n is equal to number of turns per unit length of the solenoid, then total number of turns in the length L of the solenoid, if PQ is equal to L, will be equal to NL. Capital N is equal to N into L, total number of turns in the length L of the solenoid. And then line integral magnetic field B dot dl. B vector dot dl vector P2Q plus B vector dot dl vector Q2R plus line integral B dot dl vector R2S plus line integral S to P B dot dl. So we have separated this closed line integral B dot dl into 4 integrations from P to Q, Q to R, R to S, and then S to P. But this is also 0, this is also 0, this is also 0. So line integral B dot dl will be equal to only P to Q B dot dl, because from R to S there is no magnetic field, it is lies outside the solenoid. So magnetic field will exist inside the solenoid only. Wire carrying current produces magnetic field along the solenoid only. PR and SP are perpendicular to the magnetic field. So therefore angle between B and DL will be 90 degrees. So cos 90 is 0. So all these three integrations are 0. So we have B dot DL line integral closed path is equal to P to Q B dot DL, or B dot DL B DL cos 0. So theta is 0. Angle between DL vector and B vector is 0 from P to Q. So it will be can taken outside, like magnetic field is uniform, P to Q DL. So P to Q DL is nothing but L. So total magnetic field, line integral magnetic field over the closed path is equal to B into L. This is first equation. Then by applying Ampere's substituted law, line integral B dot dl is equal to mu naught into total current through PQRS. Total current through this total length of solenoid. So if I is the current through each turn, then total current flowing through the whole solenoid of length L will be NLI. So line integral B dot dl is equal to mu naught NLI. We have to find total current, which is equal to current per turn into number of turns of length L of the solenoid. So comparing 1 and 2, so BL is equal to N mu naught Li, LL cancels, B is equal to N mu naught I. So which is required expression for magnetic field due to a solenoid carrying current at a point on its axis which lies well within the solenoid, that is inside a long solenoid or at the center of long solenoid. Because length of solenoid is very large as compared to its radius. If constant current is flowing through a solenoid, then magnetic field will be constant. So purpose of magnetic field is to produce uniform, purpose of solenoid is to produce uniform magnetic field well within the solenoid. If solenoid is large, very long, at one end of solenoid, magnetic field becomes half of the magnetic field at the center. So B is equal to N mu naught I by 2. Then another shape of solenoid is known as toroidal solenoid. It is endless solenoid. Suppose we have a solenoid like this having large number of turns and we make it as a converted to ring. So it becomes endless solenoid. It is also called endless solenoid. So it is a circular ring. Central part is empty. This is the axis of solenoid. And suppose R is the radius of solenoid and large number of insulating wire, copper wires are wound on the circular ring which form the endless solenoid, or it is known as toroidal solenoid. It is in the form of torus. So to find magnetic field at a point on its axis, let P be any point on the axis of the solenoid, again current is passing. Suppose there are two paths, one is inside, this is loop 1 and this is loop 2. So we will find magnetic field at a point on its axis of solenoid or in this region or outside the solenoid. So let us suppose line integral B dot dl again is equal to B dot dl, B dl, cos 0 is 1, so B into line integral dl. So dl will be for the radius, so it will be total length into line integral dl will be equal to total length. Total length is in this case 2 pi r, not L. So B into 2 pi r, circumference of this radius of the ring. Then n, suppose small n number of turns per unit length, total number of turns will be n into 2 pi r instead of n into L in case of straight solenoid. So total current will be I into total number of turns 2 pi r into n. So total magnetic field line integral B dot dl by Ampere's substituted law is given by mu naught in total current. So it will be mu naught 2 pi r n into I. So comparing 1 and 2. So 2 pi r cancels. So B is equal to n mu naught I again. So on the axis of toroidal solenoid, magnetic field is also B is equal to n mu naught I. Constant current is flowing, magnetic field will be uniform. Now at point Q and N, at point Q which lies in this region in the solenoid and N point lies outside on this loop, there will be no magnetic field. B is equal to 0 because this loop or this loop doesn't enclose any current. So current is on the ring, so it will produce magnetic field along the axis of the solenoid only. So this is due to solenoid. The purpose of solenoid is to produce uniform magnetic field. The solenoid is nothing but large number of copper wire turns wound on a cylindrical frame which are placed well insulated from each other. So in the form of helix, you can say. So whose length is very large as compared to radius of the solenoid. And magnetic field produced due to straight solenoid or toroidal solenoid at a point on its axis is equal to B is given by B is equal to n mu naught I. This is all about magnetic field due to solenoid, which is very, very important. So all the best. Be happy. Take care.